So, we haven't looked at this page in a little while. How to think like a computer scientist, learning with Python. If you ever get stuck on something in Python, this is not a bad place to go at all. I would just kind of bookmark it. Most of y'all are going to take scripting. Even if you don't take it from me, this is a good resource. So, as I've mentioned before, what is called an array in the textbook is implemented as a list in Python. Now, what's the difference between an array and a list? An array is fixed in length. You ask for 10 spaces, you got 10 spaces. You're not going to magically be able to make it 11 or delete something from the middle. Lists, on the other hand, expand and shrink as needed. You can start off with an empty list and then start adding things to it, which is really, really useful. The expense involved is that it takes a little bit more time for the computer to handle a list than it does an array. An array is the fastest possible data structure for handling a sequence of values. Lists are a little bit slower. Structure behind the scenes is a little bit more complicated. But Python is not the fastest language in the world. The gains you get from being able to write code quickly that can append to the end of something or delete things from the middle is so significant that if you have the ability to use lists, you really ought to. And so the guy who implemented Python, who wrote Python, decided that's all they was going to do. Didn't even need arrays. And it works. It works for Python because you can use a list to do the same kind of things that you can do with arrays and then more. So far, I think we're on lecture N. So far, we've seen two ways of allocating an array. One way is to use an initializer list. Dogs equals Fido, Dino, and Scooby. There, we've created an array of 3 strings that way. Or it could be a series of numbers, right? Scores equals, and I'm not going to put quotes around it because these are supposed to be numbers that you could do math with. 100, 90, 95. The other is to allocate it by number of elements. So, if I need an array that is 20 elements long, but I'm not going to start, I don't want to initialize it with any data yet, I just want it to be all zeros. An array 20 elements long of all zeros would look like this. I'm just going to call this one array, for lack of a better name, is equal to, well, it's supposed to be 20 elements long, so 20 asterisk, and normally I take all the spaces out, so it looks like this. And it's supposed to be all zeros. Now, we've talked about 2 ways of printing an array. By value, like this. Well, wait. First, there's the cheap and cheaty way. Just print the array, right? Print dogs. Print scores. Print parentheses array. Why do I call it the cheap and cheaty way? Well, not all languages let you print out an array like this. C and C++ certainly do not. I do not believe Java does. So if I run it, lecture N, Here it goes. It prints the array like that. Notice it looks remarkably the way we initialized it to begin with, right? Except it's using single quotes rather than double. Either work fine. Right, and then that one where we made 20 zeros, yeah, we can see it there. Printing it with a loop. We're going to use a value-based for loop rather than a range-based for loop. To count numbers in sequence, we've been using range. Now we're going to use value-based for loop, which looks like this. And remember, these variable names are just for our purposes. The computer doesn't care whether I call that value, you know, or McGillicuddy. It would work just as well as long as I use it consistently in every place it needs it. So for value in dogs, colon, print, parentheses, value. All right, now I'm going to make a mistake. If I'd asked you on an exam to write a loop that would print out the array, quite often, don't do this, people would do that. That'd be a mistake. Here's what it does. Did I really want it to print the array 3 times in a row? No, I want to print the value. Like that. Okay, and so it printed out the elements of the array. So why bother doing that if we have the nice shortcut? Well, because usually the user's not going to want to see, anything like this. We're not going to be able to add these numbers up or do any processing on them. It's just a shortcut for a way to, print out the array on the screen for the programmer to see what it has as, some kind of debug step. You wouldn't show that to the user. A customer would not want to see data formatted like that. You need to know how to use a for loop to step through an array, because if you keep programming, you're going to wind up doing that over and over and over. And by the way, if you get the idea of arrays and loops and variables and functions, modules, and if statements, then you pretty much already are a programmer. So we're doing a little bit of review today after we recap some of the arrays discussion. All right, let's write another one for the scores array. I could do it exactly the same. I could write for value in scores, print value. And then I could do it for the array the same way. For value in array, print value. It's just the same syntax over and over and over. To prove my point about the variable name not being important, I'm going to give this an absurd variable name. I'm not sure what could be more absurd than calling a variable Becky. For Becky in scores, colon, print, parentheses, Becky. That works just as well, right? I just got to make up that variable name. And it worked great as long as that's the variable that I print out. I'll loop back to that idea in a minute. Now, is Becky a good variable name? No. Since this is a value-based for loop, I like using the word value as my variable name. Another one you could just use is V, right, for value in scores. You could call it E for element, for every element in the scores list. You could even do this. And in one way, I absolutely love it, right? For each score in the scores list, print out the score. Makes perfect sense. The only problem is when you have two variable names that differ only by whether it's a plural or a singular, whether there's an S at the end or not, it is way too easy to mix it up, right? For score in scores, print scores. That's wrong. It looks good, but it's wrong. Why is it wrong? It's going to print out that 3 times in a row, and that's not what I wanted. So, although this is really tempting and it's a good syntax, you just have to be real careful not to mess it up. So you could call it value in scores for V in scores. I'm going to go back to value. Right. For value in scores, print value. Go ahead and print out this one the same way. You can do it now. You have 2 examples on the screen that differ, only by 1 word. So write one more loop that's going to print that thing.
and run it, make sure it works. And if you came in late, you don't have to catch up with all this stuff. You know that I don't count off if you don't, enter every single line that I do. So just pick up to where we are now. All right. So I'm sure you all did something like this. For value in array, colon, print value. Now, it could be that you want something a little bit more educational than just printing the value. Right? Sometimes we put a comment in our print statements explaining what we were printing out. So, for example, for value in dogs, we could have been a little bit clearer, right? Because right now it's just printing out these values. Right. Woohoo! It printed out all the zeros. Okay. Oh, and hopefully you saw my announcement that said that after you write your code to create an array of 1,000 elements, you can shorten it. Why did I say that? Because seeing 1,000 zeros in a row on the screen just isn't that educational. So, but, it'd be nice to have some kind of description as to what these things are. So I'm going to go back and modify my print statement. Now, this is perfect code. If I ask you to write, I'll add that as a comment. If I ask you to write a loop to print the dogs array, this is perfectly fine, right? That works perfectly fine. But it might be better to do it like this. I'm going to add one after this. But it might be better to do this, right? So for value in dogs, colon, print, parentheses. Now what are these? These are dogs. Dog space equals, end quote, comma, value. Now it looks a little better. See what I mean? Dog equals Fido. Dog equals Dino. Dog equals Scooby. Right? I could do the same thing with these, right? If these are scores, I could add something right there in quotes, and a comma indicating what it is. And since we don't even really know what these numbers are, I'm going to go and shorten that 20 down to like 10 or something. It's a little bit excessive. For an array, 10 elements on your homework, if you haven't done it yet, you change that, 20 to 1,000, and then boom, you've got it done. But anyways, like that, that makes the output look a little bit less ridiculous. All right, so part of the homework was to calculate the sum. The book shows a long way of calculating the sum, and it's a perfectly good way of calculating the sum. I'm not going to even call it a cheaty way. It's the most efficient way. Python can calculate the sum of a numeric array with the sum function. Remember that a function and a module are the same thing. So we have an array of scores. Total equals sum, parentheses, scores, parentheses. Now the question, where'd that total keyword come from? I just made it up. It's a good representative variable name. I could have called it McGillicuddy. I could have called it Becky. Total's a perfectly good name. The only one that's a bad name would be sum. Whenever you start to type a variable name and it comes up purple, pick another one. The reason why is this would erase the function in memory and we'd no longer be able to call it. Might work the first time, but after that, if we ever tried to call sum again, like that, it's going to fail. We have erased what the sum function used to be when we do that. I mean, it's not like it messed up your computer and the sum function will never work again, but it's not going to work for that particular program. So that's a nice way of doing it. Here's the longer way of doing it, which is what the textbook would focus on. Or you can do it with a loop. If I was going to calculate everybody's age, I'd go to somebody's, the total of it. I'd go to the first person, student 0, and say, what's your age? And I would add it to my total. What's your age? I would add it to my total. What's your age? What's your age? Right?
However, you have to have a total to begin with, just like our summation in our for loops
A while back, right? So total equals 0, right? You can't start adding something unless you have a 0 to begin with. And then we just use a loop like this, right? This worked perfectly good to print out the values. It'll also work perfectly good to add them to our total. So for value in scores colon total plus equals value. Now don't do total plus equals scores, right? That's just like when we accidentally had scores here and we printed out that strange looking list 3 times in a row. No, we want to add each value to our total. Okay, now that's the fastest way of doing it. Knowing how to do this is a good thing to know in your computer science CIT career. Next time you go and take another programming language, you're going to see it again. So if I ask you to write code on an exam that calculates the sum of an array, feel free to go with this one, right? This is great and good for an exam, right? Now lastly, parallel arrays. We've mentioned them already. Parallel arrays are multiple arrays of the same length where the items are linked by their index value, the subscript. We haven't even seen any subscripts so far. But what's the special symbols that represent a subscript in an array in this language? And pretty much every language. Yeah, the square braces. Yep. Yep. Square braces are the subscripts. So if we decided that our first score was incorrect and they actually needed extra credit, we could change it, right? Scores 0 equals 105, right? They got extra credit. No longer is it 100, it's 105. But then we decided that they didn't put their name on their exam. Yeah, this is stupid, right? And so we're going to deduct 10 points from whatever they made. Scores minus equals 10, right? So what is this showing? One, it's showing the subscripts, the index, right? We changed the first value of the scores and we changed the second one. The other thing we're showing, let's do one more. Scores subscript 2 equals scores subscript 1 plus 2. Whatever. I'm just making these things up. But what's it showing is that you can use an element of an array just like any other variable, right? If I had x equals 105, great. I can have scores subscript 0 equals 105. I could have x is equal to y plus 2. Well, instead of y, I could put scores subscript 1. Every element in that array is exactly like a variable of that type, whether it's a string, a float, or an int. All right, so parallel arrays. Multiple arrays, like 2 or more, right, of the same length where the elements are linked by their subscript. We used Excel as a demonstration of that. For example, I might have somebody's name, I might have their age, and I might have their ID number, right? And so Joe is 30, and his ID number is 234, whatever, right? Kim is 25, and her ID number is, 5, 6, 7, 8, 9, whatever, right? And Sam, he's a youngster. He got ahead in college. He's only 16. His ID number is, 898 or whatever. And then one last one. Billy. Billy's retired and come back to college. 68. He has a really low ID number because he came here a long time ago. All right, there we go, right? These are parallel arrays. In effect, we have an array called name, an array called age, and an array called ID. And if we wrote their index numbers down here, 0, 1, 2, and 3, right? So in the name array, element 0 is Joe. In the age array, element 0 is 30. And in the ID array, element 0 is 2, 1, 3, 4, 5. So Joe is 30, and their ID is 2, 1, 3, 4, 5. Let's play with that idea. We're going to go back up and do some cats now. Cats equals Felix cat. So cats equals square brace, quote, Felix, end quote, Sylvester. You can put whatever you want here. Fluffy, right? And now their colors. Colors equals Felix is black and white, whatever. I'm going to say black. Sylvester is gray. And Fluffy is white. And now their birth dates. Birth is equal to, Felix is born in January. Sylvester was born in March. And Fluffy was born in December. Yeah, I could type out a whole date, but, what's the point? And just make it, more typing. These are parallel arrays. Felix is black, born in January. Sylvester is gray, born in March. Fluffy is white and born in December. So what's the index number of this value right here? What is that subscript? 1. Awesome. Because this is known as zero-based indexing, or what I always say, our computers always start counting at 0. That's at index 0. That's subscript 0. Subscript 1, subscript 2. So if we did this, print parentheses quote, no quote, cats subscript 2 in subscript, colors subscript 2 in subscript, birth subscript 2 in subscript, in parentheses. It's going to print out Fluffy White December. We might want to print that out with a loop, but we're not going to be able to do it with a value loop. Why? Because if we use a value loop, we're not going to have anything that gives us a 1, a 2, a 0, or whatever, right? If we use a value loop, we're going to get the words Felix, Sylvester, and Fluffy, or black, gray, and white, or January, March, and December, which is not going to help us do anything like that, right? We need these numbers. We need 2, 2, 2, or 1, 1, 1, or 0, 0, 0. That's a job for a range-based loop. We need a range-based loop to get a counter that's going to go 0, 1, and 2. I'm going to run this and make sure I don't have any syntax errors at this point. Right? And sure enough, that's that cat, Fluffy White December. I'm just going to comment that out because instead I'm going to print it out with a loop. You use range-based for loops for parallel arrays. You could also call it an index-based loop. Since it's an index, I like the letter I. I could use the whole word index. Why not type I? It's shorter. So, I don't know though, we were using the whole word value, so why not use the whole word index? Well, because we're going to probably have it 4 times in our print statement. So, for I in range, 0, comma, I could put like 3 here, right? Because I need it to go from 0 to 1 and 2. But what instead I'm going to do is I'm going to erase that stuff, and I'm going to use the length of one of these arrays as my range. So that if I suddenly went and added more cats and more colors and more birth dates, I wouldn't have to change the range, right? I wouldn't have to go and change 03 to 010 or something like that. So inside the parentheses, I'm going to do len parentheses cats in subscript colon. This is just a function that goes and counts the number of elements in the array. Well, how many are there? I know it's tempting to say 2 because, 0, 1, and 2, but there's 3 elements in it, right? If we called len birth, it'd still return 3. If we called len of this array way up here, it would print 3 because there's 3 elements. If we called len of that variable, it would say 10 because there's 10 zeros in that array. All right, so here, why don't we print out the index number first? Print I, comma, you don't have to, but it's nice to see that index number, 0, 1, and 2, 3, 4, 5, 6 if we had more. Not necessary. What is necessary is I want to print out the cat, the color, and the birth date. So, cats subscript I in subscript, colors subscript I in subscript, and birth subscript I in subscript in parentheses. Now when I run it, it's going to print it out in a table. It's not going to be a really nice table. It's not going to be lined up in columns. I could try to fix that, but I'm not going to. It makes it more complicated. It takes scripting to learn how to do more awesome stuff like that. All right, here we go. Right. Cat number 0 is a Felix, is a black cat born in January. I'll bring the code back, don't worry. Cat number 1 is Sylvester, who's gray and born in March. Cat number 2 is Fluffy, who is white and born in December. And yeah, we could add some comments, right? We could add some quotes to make it much more, much more explanatory. So that's parallel arrays. That is about enough review. I'm going to suddenly veer off and we're going to talk about lists rather than arrays. What did I say was the big deal about lists? You can append to them. You can delete from them. Something like this. I'm going to make an empty list and then start appending things to it. What does an empty list look like? All right, I'm going to list some movies. Movies equals there. Well, what's that? It's an array with nothing in it. It's called an empty list. We have switched gears to actually talking about Python lists rather than textbook arrays. Lists can do everything arrays can do and more, so everything we've done so far is with arrays. They just happen to be implemented using lists in this language. All right, let's add some movies to it. Movies.append, I don't know, Star Trek Beyond. I'm not fond of the movie, being a classic, fan of the old series, but it's a movie, certainly, nonetheless. So movies.append, and you don't have to put Star Trek there, you can put anything you want. And then movies.append Hobbit 4, The Revenge. Whatever, I just made that up. All right. Movies.append, add something else. Whatever you feel like. A movie you hate, a movie you love. I don't know. Twilight. No one always gets a response. Alrighty. Maybe one more, just for grins. Movies.append Jaws. Going to the 70s. We like fish. There we go. Now we have an array with 4 elements in it. Is anybody not going to be able to be here Monday and we need to make arrangements for you to take the exam like on Tuesday at the library? It's true in some of my classes.
That sucks.
Which is too bad because it's cooler to take it in here and be able to ask me questions. All right, let's print out those movies, but let's do it the cheap and cheaty way just because, right? Heck, let's put a description. Movies list equals, end quote, comma, movies. All right, and it printed our movies list. Star Trek Beyond, Hobbit 4, The Revenge, Twilight, and Jaws. If we had filled up one of these arrays up here, and we were limited to arrays, we did not have the concept of lists. If we wanted to tack on a 4th dog, Snoopy, or whatever the dog's name is in Adventure Time, or whatever, then it'd be a real problem. We'd have to allocate a brand new array of 4 elements, and we would have to copy them in one by one. Just like if you have an apartment complex with 200 buildings and you wanted to move, build one, add one more apartment to it. Well, in array land, you'd have to go and build a brand new apartment complex somewhere else with more rooms and then move everybody into the new apartment complex, and then the new person can move it. Now, that sounds like a lot of trouble, right? Build a brand new apartment complex, just to add one to the end. That's a drag, and that's kind of the drawback to arrays. So, arrays are fixed in length, and every element in an array has the same type by textbook. Languages can vary from that, but by textbook that's true. And if you keep that thought in mind, you'll never go wrong. And even the languages that do support different things. Just because a language allows us to do something doesn't mean we ought to do it. The English language allows me to say, I ain't not gonna never go home. And I could try to figure out what that means, but that doesn't mean I should say that because it's confusing. Lists are not fixed in length. They can grow or shrink as data is appended or removed. Textbook ain't even gonna mention lists. If lists show up in the exam, I'm gonna give you the answers. And the reason for me including them would be so that y'all took, the same questions as the last semester did. So that next semester I could reuse that exam, and look at it to plan the next one. All right. Now what else can you do with arrays? The book talks about searching, doing a linear search. I want to find somebody who's exactly 28 years old. So I started student 0. You 28? Nah. You 28? Nah. You 28? Yeah, found one, right? I checked student 0, 1, and 2 until I found it. That's a linear search. Linear means in a line, right? So, going from the beginning of the array to the end. If you have a question, yes, sir.
What is this thing? I don't know what that is.
Uh-oh.
I thought it was kind of weird.
Aha.
3 quotes, 4 quotes.
I didn't know that was a thing.
That's the kind of thing that you would probably spend 7 hours finding the first time, bitter experience, where you put dents in your everything on the keyboard. And then you never do it again. All right. So I will go to the end. Now, an optimization of the linear search is to stop the search early, right? As soon as I find somebody who's 23 or whatever, I just stop the loop. That's an improvement in efficiency, right? Because what if I had 10,000 students and I wanted the first one with an age of 23? As soon as I find somebody with it, I want to stop. If I wasn't able to stop, it'd be like playing that guessing game and then not stopping when they get the number right, right? That'd be dumb. So linear search is when you start at the first element looking for a specific value and you keep checking successive values. You know, start at index 0 and keep going. Now, I'm not going to add any comments about that, although I guess it's in the textbook. So linear search, start at index or subscript 0, going up to length minus 1. We'll talk about why we do that. Checking each element to see if it matches the target, what you are looking for. I'm looking for a student named Anna. Well, that's my target. I'm looking for a month named March. Well, that's my target. I'm looking for a month in which our sales was less than forecast, right? Or a 0. Well, that's my target. So why that minus 1? If an array is 20 elements long, you can access subscripts 0 through 19. Well, that looks weird. Why can't I access element 20? Because that's actually 21, the 21st piece, since we're starting counting to 0. If my array is 10 elements long, I can access 0 through 9. I can count them out on my fingers, right? I have 10 fingers, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. The highest I could do. Highest index I could do would be 9. So if the array is 10 elements long, what's the lowest I can do? The lowest is 0. The lowest subscript. The lowest, yeah, right. Lowest subscript is 0. The highest subscript is 9. There's a sneaky way to get to the end of the array without taking the length of the array and then subtracting 1. And this only works in Python, but hey, if the language gives it to you and it's cool, and it's not kind of cheaty like printing out the array is with one command, then you might want to use it. So we have that cats array, right? Or maybe we can make a new array. I don't care. L, that's our new array name, equals, and I'm just going to type in some numbers separated by commas. Doesn't matter how many. Whatever, right? Add as many numbers as you want. Please don't take the trouble of typing in my numbers. Now we want to print the last element. Okay, here's the way that's not full credit if I asked it for you on an exam. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to print out L subscript 11. Now I said that's not full credit, right? Why? Because if I had any more pieces of data in it, or I removed some, it'd be incorrect and it might even crash the program. Because if you try to go past the end of the array, you crash the program. It's called out of range. So here's the right way to do it. 2 ways, hard way and an easy way. Print L subscript. Now I'm putting lots of space here because we're going to put something a little bit more complex in here. We're not going to put a number.
Remember that len function that gets the length of the array? Between the square braces, as my subscript, I'm going to put len, parentheses, L in parentheses, minus 1. And yeah, I could remove all those extra spaces. It's just to make it real easy for you to type when you're looking at it. That's one way. Now conveniently, nicely, and I wish that every programming language had this, not just Python, to get the last element of the array, you can start counting negatively. -1 is the last. -2 is the second to the last. So the subscripts can go negative and they just go, from the end rather than the beginning. That's really kind of cool. I wish C or Java, or C# or all those other languages did it. What if we wanted to find out if a specific value was in the array? I had an array of names and I wanted to find out if Joe was in the array. I have an array of numbers and I want to find out if 234 is in it or not. There are functions to do things like that. There's a syntax for checking to see if something is in an array. Here's how to check to see if a value can be found in the array. If, and what value am I going to look for? Put some number that's actually in your array, right? In my array, there happens to be a 45, so I'm going to put that there. So if 45 space in space L, and remember I said variable names are meaningless. I could, change this variable name to anything as long as I used it there and there and there and there. It's all right. If 45 is in L, I'm going to print a message saying, yes, I found 45. End quote. All right. That's how you search. We could tack on an else saying 45 not found. Else, colon, print 45 not found in L. End quote, in parentheses. So when I run it, it should print 4 2 times in a row, right? Because that's the last element of the array. The first time we printed it out by calculating the length and subtracting 1. The second time we just use that handy -1 shortcut as our subscript. And then it's going to print, yes, I found 45. Because in my array, 45 happens to be in it. If it's not in yours, you're going to get that message. And in mine, there was a 45. If I change that 45 to something else, like 45, 46, then when I ran it, it'd say no, 45 was not in there. So this syntax, the if value in array syntax, checks. So use if value in array to check to see if a value can be found. All right, now we're going to blip over to that website once everybody's got this going with no syntax errors. Anybody who's actually trying to get it going. How to think like a computer scientist using Python 3. So where can you find that? If you go to our modules, scroll down to online textbook, click how to think like a computer scientist. You're trying to launch insecure content. Okay, great. I want Lists, remember they were called lists. Here we go. They have a slightly different definition. Lists in this language are more flexible than arrays. One of the differences is that a list can hold data of different types. I can append a number, then I could append a string to it, and then I could append a turtle, right? You know, anything. That, to me, kind of messes with the idea a little bit too much, but it does give some flexibility. So the values that make up a list are called its elements. Same thing with arrays. Or items. Yeah, well, elements is the term the book uses. We will use the term element. Okay. So several ways of creating an array. Here's one. That's the simplest way. Enclose the elements in square brackets and square braces and separate them by comments. And then they don't show the other way. Well, I did. Remember when we did 20 asterisk square brace 0? That's the other way. Accessing elements. Start at 0. That index has to be a whole number. You can get a whole number by doing math. There's nothing wrong with saying I want index value 9 minus 8 if you mean 1. But if you try to use a floating point number, you know, what is array element 1.5? Well, yeah, at the Hogwarts train station they might have, you know, platform 9.78 or whatever, but in our world, you know, whole numbers. So if you try to access an element that doesn't exist, it'll blow up. If numbers is only 2 elements long, we can get 0 and 1 out of it, and if we stick 2 or anything larger, we're going to get a crash. Now here's an interesting thing that I never do, but you can make a for loop that counts through an array that you define right on the spot. I guess that's worth demonstrating. I don't necessarily want you to burn this into memory and sweat about it, but for, I don't know, hero in, and I'm going to make a list of heroes. Who's your hero? Jefferson, Thomas Jefferson, right? Comma. Tony Stark, why not veer off? And I'm fond of scientists, so I'm going to put Einstein in here. All right, so, and then I'm going to put a colon at the end of that. And I'm going to print out my hero, right, quote, my hero is, end quote, comma, hero. So it's going to print out 3 lines. It's going to print out my hero is Jefferson, my hero is Tony Stark, and my hero is Einstein. That's kind of specific to this language, so it's worth seeing. We see it in the slide, excuse me, on the page, but oh, I better make sure that it's not a syntax error, so I'm going to run it. All right, there we go. So, as you go through the loop, or I should say as the computer goes through it, that's called traversal. We're traversing the array. We're traversing the list. We have 4 horsemen of the apocalypse, war, famine, pestilence, and death. Yeah, let's get nice and grim. If our for statement is for H in horsemen, print H. Well, that works just fine, except we were using the word value there. Variable names don't matter to the computer. They only matter to us. If you feel like using the letter H rather than the word value, hey, great. Works just fine. What if you want to know the length of the list? You want to find out how many horsemen are in our array, in our list. That's where you use that len function. List membership. I want to see if pestilence is in the horsemen, right? That's the same thing that we did when I was checking to see if the number 45 was in there. I just put if in there in front of it. But is pestilence in the horsemen? Yeah, true. Is debauchery in the horsemen? No. This is showing embedding lists within lists. That's very Python specific. Let's just scroll right past that. If you want, in this language, you can add a list to a list. Feel like adding our cats and our heroes? We could do that. We can make a new list that has both cats and heroes in it.
Is that a vector? Almost like the same thing.
Exactly. A list is a vector. You're so right. Okay, so like, I don't know, friends. I have some good friends who are my cats plus my hero. Well, no, I don't have a hero list. I defined it right then on the spot. But surely add something else. Somewhere. Dogs, right? My cats plus my dogs. Now, if you didn't type in the dogs because you came in late, then just comment this line out. It's not going to work. Print friends. Right, there we go. There we go. My pets are my friends. We concatenated. Remember, if you use the plus sign, but you're not doing it with math, you're not doing numbers, then it's called concatenation, like when you concatenate two strings together. Concatenate somebody's first name and their last name. Well, here we concatenated two arrays, two lists. Wrong, I didn't want that. I want this. List slices. This is a really cool part of the language. And I wish that we had hit arrays. You could talk 2 weeks on lists to get the concepts burned in. You'll hit them in scripting. What is a slice? Well, I have this cool cats list or this cool friends list. I'm going to make a new array that has more elements in it just to play with. Now, I know we already had one called L, but I'm going to make a new one. L is equal to square brace. Just type some words in there. Abe, comma, dog, comma, Python, comma, and I'm not saying the quotes, right? Fred, comma, spinach, whatever. Make up your own words, right? Pac-Man, comma, right? That's enough. Now say I want a list that has the first 3 elements in it. If you were talking about strings, you'd call it a substring. Here's that syntax. I'm going to call it slist for sublist or slice. In fact, I'm going to call it slice. Nope. That came up purple. That'd be a bad term for it. So SL, the only reason I'm making it in caps is because L's and, and lowercase l's look like 1s. Alright, so SL is equal to L square brace 0:3 in square brace. What does that mean? Starting at element 3, and just like the range, element 0, and just like the range statement, where if you put 3, it actually goes up to 2. Starting at 0 and counting up 2 but not including 3, 0, 1, and 2. So when I print it out, it's going to have the first 3 elements in it. It's going to print Abe, dog, and Python, or whatever you put in yours. Print L, and then on the next line, print SL. That works for strings as well. Alrighty. What if your hero in the world is Darth Vader? Hero equals, quote, Darth space Vader, end quote. The first name of my hero, FN for first name, is equal to hero, but I'm going to get a slice. As a matter of fact, I better say what I'm doing here. Slices equals parts of the array. By the way, if vectors can do this, that's really cool. I'm not familiar enough It's vectors. So first name is equal to hero. Now what's the first letter of, what's the position of the first letter?
0.
Yeah, it's at 0. So I'm going to start my slice at 0 and put a colon there. And the position of the last letter, well, let's count it out. That's a 0, 1, 2, 3, 4. But I'm not going to put 4 there. We have to go one past it, just like a range statement. Now, one thing I'm going to mention is that if I need to start somewhere and then I want a certain number of elements, an easy way of figuring it out is to say, okay, I'm starting at 0 and I want 3 elements. So 0 plus 3 is, gives me the last number. Here I wanted 5 letters, so I started at 0 and then I added 5 to 0. I'm going to use that technique to figure out how to get the last name out of it. LN for last name, I guess I'm going to leave it lowercase. That's not a 1N, it's an LN. Is equal to hero. What's the position of that V? I better count it out. 0, 1, 2, 3, 4, 5, 6. So starting at 6, and I'm just going to say, oh, well, it's 5 letters long, so 6 plus 5 is 11. I'm not going to even count it out. I'm absolutely sure that's going to work. It's not going to crash. So that's my starting position, and I want to go 5 beyond that. Now, if we count it out, that's index value 10. You know what? I'm not sure that's true. Let's figure it out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 10. Okay, cool. So I could print out the first name, and then I could print out the last name, and it's going to say Darth on one side and 0 on the other. About time to run it and make sure it's working so we can check syntax errors since we've slipped into something we hadn't done before, which is the colon in our subscripts. Alright, and so it did. The first name was Darth, the last name was Vader. Alrighty then. I want you to come up with something. Middle is equal to, and make a slice that's going to start with the TH and go all the way up to and including the V. You pick the numbers. So here's what we came up with to answer our question about how to start at the T and go all the way up to and including the V. Python has shortcuts to make things easier, like that -1. You can leave off that last number and it goes all the way to the end of the string. So I didn't have to put an 11 there. I could have done this. ln equals hero starting at position 6, that stays the same, colon, and just don't put a second number. Just like in a range statement, if you leave that first number off, it assumes you're starting at 0. It's a shortcut. Well, if you leave the second number off, it goes to the end. So if I print it out, and let's print those out. We haven't printed the middle yet. Print middle, comma, ln for last name. We're going to see it say th space v, and then we're going to see it do Vader. Yeah, I better put a comment as to what's going on here. If you leave off the number or the index of the subscript after the colon, the slice goes to the end of the list or the string. In a minute, we'll take a roll and take a break. Okay, so we have this cool list up here. What if I wanted to start at Python and go all the way to the end of the list, and I want to do this trick where I leave off the value after the colon? What's my print statement going to look like?
2 colon, nothing follows.
Exactly. This is position 2. I want to go to the end of the list, so I'm going to put a colon and just leave the rest of it off, right? L subscript 2 colon. So start at index 2, go to the end of the list. Lists are, quote, mutable, meaning you could change their value. We've already done that, right? We changed one of the scores and then we changed another score, right? Mutable just means changeable. Like the Hulk was mutated, he changed, whatever, right? That's what mutable means, modifiable. Strings are not. So while this would work, L equals L subscript 0 in subscript equals, and I could change Abe to something else. I don't know. Abe dropped out of the race to be replaced by Lucy, right? That works. However, strings are not. So if I try to change one of these letters, that's letter 0, this is going to be a syntax error. So if I do hero subscript 0 is equal to, we're changing his name from Darth to Barth. He's feeling kind of nauseous. Stupid joke. Here we go. That's going to be a syntax error. Not going to work. I'm going to run it to prove it's an error. No, not a syntax error. It's actually a runtime error, isn't it? It might be a syntax error. We'll see. Nope. Runtime error. Boom. It blew up. So I better comment that out. And I'm going to make a comment. Strings. Nope. That kind of comment. Arrays / lists are mutable. Period. Strings are not. Mutable means the elements can be changed. So since I hate to put stuff on the exam that we only hit for the last day, this stuff's not going to be on the exam, or if it is, I'm going to flat out give you the answers. But when you take scripting, and the other people who haven't taken fundamentals have not, you're already going to be at the 50-yard line running towards the goal, and they're starting at 0. And these are good concepts to have tucked away in your brain. Beginning of the next semester is only like 3 weeks away. Alrighty, almost time for our break. Let's go and look at the slide. Here we go. Lists are mutable. So here they made a list called fruit. They made an array called fruit. It was banana, apple, and quince. You know what? I'm dumb enough to not even know what that is. Who knows what a quince is? Who's enough of a gourmand to know what that kind of fruit is? Alrighty. And so here we change the first element to pear. Here we change the last element to orange. So when we print it out, we get pear, apple, orange. Wouldn't work for strings. List deletion. If you want to take something out of the middle of the array, you can do that. Right? Say I just hate the letter A. No, I hate the letter, T. I'm going to get rid of that T. Well, I can do so using this same syntax, the del word. Well, what's that position of that T? 0, 1, 2, 3. Alrighty, so I'm going to come down here and I'm going to do del hero subscript 3 in subscript. That's going to remove the fourth element of the list. So if we printed it out, it would print out Darth Vader now, but the T would be gone. Print, quote, with the T deleted, hero is, end quote, comma, hero. That's called deleting by index, right? We deleted it by index. There's also a delete by value. Delete by value just searches the string and deletes it. Deletes that element. That'd be good if I didn't know the position of the T. Right? If I didn't know where the T was, I might want to delete it by value. Oh, and by the way, I think this is going to crash. I think this is a mistake because hero is not a list, it's a string. So when I run it, I'm expecting this line to crash, and I should have come up with a different example. Boom. All right. Because strings are not mutable. That was dumb. Erase those two things. We need to delete something from something else, like our list up here. Remember your L list? How about we just delete the first element of the list? I mean, we already fired Abe and replaced Abe with Lucy, but now we're just going to eliminate that position whatsoever. So, delete the first element of the list. L. DEL space L subscript 0. Gone. Abe or Lucy or whoever the first element of the list is now, it's just flat out gone. How about deleting the last element of the list? What did we say was a shortcut for the last element? The -1. So DEL L subscript -1, delete the last element of the list. And then we may as well print our list out again, right? I'm not sure we printed it before our deletions, so why not? I'm going to put parentheses L before the deletions and after, just so I can see that it changed. Right, so we had Lucy, Dog, Python, Fred, Spinach, Pac-Man, or whatever you had. And now the first and the last elements have been removed. And we could take one out from the middle or whatever as well. Okay, so we've seen some new stuff. What was our new stuff? We've talked about slices, which is something like this. That returns a sublist, a slice of the list from subscript X going up to but not including subscript Y. Or you can do slice X colon, goes from X to the end of the list. By the way, you can leave the first number off too, and it just starts at 0. Right? If I did this, I'm going to erase this. L colon X. And by the way, the fact that I'm using X here rather than a number, that's just like, you know, you're talking algebra or whatever, and you're saying, you know, A rather than 10. It's a variable. Okay, so what this does is it starts at 0 and it goes up to not including that position, right? So if I had that, it would start at 0 and go up to but not including 10. Now, honestly, is it that much effort to type in a 0 there? Nah. But you can leave it out.
Is print the whole thing? You just leave or have no
Exactly. That was going to be the next thing I mentioned. Right? That's the entire list from beginning to end. And that's actually useful. Maybe you think, why would I want to do that? That's called cloning the list. It gives you a brand new list that contains all the same elements copied into a brand new list. And then you could change those and leave your original list behind. Clone the list. The whole thing. Start at index 0 and go to index 9. That's what that would do. Check to see if something, or if a value is in the list with if value in L. I'm just using L now as a shortcut for the word list. Delete an element of the list with del space L subscript X. That deletes the X element. Example, del L subscript 2 would delete the third element. To add an item to a list, use L.append. Here's the example. L.append, quote, 1, 2, 3, would add the element, and make a new element called 1, 2, 3 at the end of the list. Now guess what? There's an insert as well. You want to insert something into the beginning, you can do that. We didn't even talk about it, but you can do that. You can also use .insert to put something into the beginning of the list. Or you can use .insert to put it in the middle. You just have to specify the index value, right? If you have a list of 10 items and you want something to be the new third item and you want to push everything else down, you could insert into position 3. And then what was 3 becomes 4, and so on down the line. Let's stop here for now. Take a break. All right, just a few more things about lists. And we'll talk about the exam. Let's use that insert command. Three quotes. J for Jenny's phone number is equal to 8, 6, 7, 5, 3, 0, 9. For some reason, I want to stick a 4 at the very beginning of that. Maybe we're going to insert 405, one at a time. J dot insert 4. I believe that'll work. I believe I don't have to specify the position. Let's find out if that's the case. Nope, it takes 2 arguments. I was wrong. I want 4 to become the new position 0. So I'm going to insert the 4 at position 0. Put 4 at index 0. Now, for an Oklahoma, at least this area code, we need a 0 in the second position. 0.insert a 0, and I want it to be in the second position, pushing everything after that down. And what are we going to do with that 5? You tell me what we're going to do to insert the 5 in the correct place. Insert. Well, what's the number we're inserting?
5.
5. And what position?
2.
Yeah, because we want it to be the third number. So this, put a 0 at index 1, and this put a 5 at index 2. So up here where I said you can use insert to put something into the beginning of the list, I'm going to say put something into the beginning list, parentheses, or at any specified index. And let's just go ahead and give our example. L.insert, parentheses, Bob, end quote, comma, 0, inserts Bob at the beginning of list L. Let's print out Jenny's phone number. Jenny's phone number, end quote, comma, J. And there we go, Jenny's phone number. Oh, where'd my 405 go? My 4, my 0, and my 5 went. Did I use the wrong variable name? I'm kind of lost as to why that happened. We started off with 7 digits. After we ran, how many characters were in it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I have them swapped, I bet. I bet you specify the position first and then the value. Let's try that. 0, 4, 1, 5, wait, 1, 0, and then 2, 5. And I'm going to need to modify my comment. That's much better. All right, my mistake. Sorry about that. Switch between languages. Each one has its own syntax. All right, so I need to change my example up here to make it say insert 0, comma, quote, Bob, end quote, in my comment. And you know what, if I did ask you, which I'm not going to do, you know, or if I did, I'd give you the answer for you to tell me how to insert something into the beginning of the list. If you put the 0 in the second spot rather than the first one, I'd certainly give you half credit because you have the idea. All right, let's go back. Anybody need this page anymore? I mean, okay, I'm coming. Anybody getting syntax errors that you wish? All right. I'm just spacing this out a little bit. Good enough. All right, that is enough about lists, except we did not talk about how to delete by index. And I didn't even see it on that page. So, Python remove an element by index. Oh, well, no wonder, because I hate it. It's called .pop. I really don't like that 4 anymore. But I don't know what's at that position. J.pop, parentheses, 0. removes the first element from the list. J.pop parentheses -1 removes the last element from the list. And it doesn't only remove it, it returns the value as well. You could store it as you call j.pop. And if we did like x equals j.pop parentheses 0, then x would equal 4 because that's the first digit. And if we said y is equal to j.pop -1, it would make y equal to 9. So let's just put a little comment here that we can remove by index number. And I already talked about deleting by value, but it's worth mentioning again. Delete by value. Jenny really doesn't like 3s. So we're going to delete parentheses. I'm goofing up on this. Let me go look and see how. Yeah. Totally messing up. We didn't need pop. We already had something that deleted my index. Well, phooey, I'm going to delete all of that stuff. Alrighty. I made you type 20 pages and then now I'm deleting it. How about that? So let's Python remove an element by value. Alright, it's .remove. So I want to get rid of that 4. So j.remove parentheses 4. That'll remove the 4 from the phone number. Searches the list for 4 and removes it. Let's print the list to make absolutely sure that's a true statement. Right, now the 4 is gone. So this is deleting by value. Delete by value. And this is delete by index. DEL J subscript 2 deletes the element at index 2. And why not mention 2 more things? There's a function that returns. Do you remember the in function, like if x and y? If there's a t invader, if t space, or if t in hero, right? That kind of thing to check to see if something is in the list. You can also check to see if it begins the list. Okay, that's kind of lame because you can just compare it to element 0. Tell you what, we are going to skip that because you can just check element 0 for the beginning and you can check element -1 at the end. So forget that. It's more appropriate to strings. We're going to blow it off. Alrighty, so uno momento. Looping is where this unit began, I believe. Or maybe it was the last thing of the last unit, but we're going to have some stuff on it again. How to write a loop that counts from 1 to 10, right? That's the kind of question I could ask on that. By ones. Right? Or I could ask something like how to write a loop that would count from 2 to 30 by 2s. I don't mind giving you the answer, but I know somebody can get me one. So for I in range, what would my first number be for the second question? Somebody can give me the starting value, I'm sure.
3.
Well, not 3. I want to go from 2 to 30. So yeah, start at 2. What's my last number going to be? Everybody's familiar with this idea by now. If I wanted to stop at 30, then this should be
31.
Yep. and I want to go up by 2's. So what's my third value going to be? And then on colon, and on the next line, I'd put just print I. Know what a loop looks like on a flowchart. Loop on a flowchart has the diamond, and then the line goes back up to the diamond, as opposed to an if statement, where they separate and then they come back in a circle underneath. You'll get a last little minute review of that because you're drawing a flowchart for the guessing game. If you get stuck, if you want me to eyeball your guessing game flowchart early and you haven't already uploaded it, just, text me a picture of it and I'll go, yeah, that's great, or else I'll, grab my stylus and draw on your thing and send it back. You already know this, but know the difference between a single and dual alternative if statement decision. We know what a nested loop is. We didn't have a nested loop in the guessing game, but we had a nested if statement inside a loop, right? We had while, secret, not equal guess, something like that. So we could keep guessing as long as the guess was wrong. So we had a while, and then indented inside it, we had an if statement. So the if was indented inside the while. Nested loops, you have a while, and then you have a tab, and you have another while. Or if it was in a flowchart, you'd have a while diamond, and a line coming over to another while diamond. So that's a nested loop. So know what it looks like in flowchart and code. There's not going to be any pseudocode questions, by the way. We're grown-ups. We don't need pseudocode anymore. That's a silly term. Pseudocode has a very useful purpose, right? For describing code in a, quote, language agnostic way, meaning for any language, not just Python, but we're kind of past it. If we had a loop that looks like this, for x in range 10, colon, for y in range 20, colon, print something. Hi. How many times would that print? I'm going to put some wrong answers here. Would it print 10 times? No, it's going to print way more than 10 highs. Would it print 20? Here's one that might get people. Would it print 30? Yeah, 10 plus 20 is 30. No, it's going to print 10 times 20 for 200. 200 is the correct answer. Just multiply 10 by 20. I really wish I could have found it. Using a post-test loop. I'm going to skip it since it's not in Python. Characteristics shared by all structured loops. What are those characteristics? You initialize a loop control variable, you have a comparison, and you have an update. Now I want to get the exact words that they use. You let me open yourself? I guess I can go and find the old copy of it. Here we go. Alright, so the characteristics. Well, this isn't quite what I was looking for. The loop controlling evaluation must provide the entry or the exit from the structure. Yeah, that's the while condition. And the loop controlling evaluation provides the only entry or exit to the structure. Right? There's only one way to get into it. You couldn't have some kind of if statement that sneaks a line over here. There's only one way into it. That's via the diamond. Here we go. Here's the three things that your classic loop will do. Even if it's a for loop that's stepping through a list, unconsciously or in the background, it's doing this. The loop control variable is initialized, right? Set x equal to 0 or whatever the starting value is. If you have 4x in range 10, 20, it's initialized to 10. And then the loop control variable is tested. Keep going while it's less than 20 in that range 10, 20. And then the body of the loop must alter the value of the loop control variable. X keeps counting 10, 11, 12, 13, 14, 15. Or if we had that list, right? For value in list, it gets initialized. Value is set to the first element of the list. Each time it goes, the loop control variable is tested to make sure it's not at the end of the list. And then each time it goes, the loop control variable gets updated with every subsequent value of the list. Worth commenting upon. Okay. Loop characteristics. Parentheses, controlling repetitions. Loop control variable, which I'm going to abbreviate LCV, is initialized. I guess I better put parentheses to indicate that it's just initials. And then the LCV is tested, and then the LCV is updated. That's a classic loop. There are some kind of loops that don't follow that. It's called a while true loop, which just runs endlessly until it hits a break statement. But this is enough. I'm going to number them even to make them easy to see. So classically, here's a classic loop example. Write a while loop that will count from 1 to 10. Well, step 1, the loop control variable has to be initialized. Why don't we just call it I? I equals 1. That's our loop control variable. Initialized to 1 because we're going from 1 to 10. While I is less than or equal to 10, or if you feel like making it a range statement, you can make it less than 11, right? Either one would work. Don't make it less than or equal to 11 because it's going to count to 11 rather than 10. While I is less than or equal to 10, colon. We might print it out. Print out I. So we have done steps 1, 2, and now we need step 3, which is updated. I plus equals 1. You already know how to do that in the for loop. You know how to do that in a for loop, but you already do. Smiley face. There we go. How unprofessional is it for a professor to put emoticons in their notes? But if you don't, If you look at that and you don't think you could do it, give it an attempt and then text me and ask if you got it right. Common loop applications, I guess we can look at that. I don't think I'm going to ask you that. Let's go look. Oh, one incredibly important thing that I'm not seeing it here. Sentinel value. What is a sentinel value? It is the value that stops the loop. There's a fancier way of saying it. It is an invalid value that stops the loop. But when I said that, when I said invalid value, some people rebelled and said, what do you mean invalid value? Is that going to crash the program? And it's not a stupid question, right? Because invalid value makes it sound like it's something to be avoided. No, it's just the value that stops the loop. If I write something that says enter a number or -1 to stop, or enter a name, or type Q to quit, then that -1 is a sentinel value, or that Q is a sentinel value. So example, enter a number or -1 to quit, or enter a name or Q to quit. If you're a Star Trek fan, there really is a character named Q, so that would be a bad choice. So the sentinel values are -1 and Q. And you can pick any sentinel value you want, but it better not be a valid piece of data. What do I mean? If it says enter a value or 7 to quit, and 7 is acceptable data, right, or enter a test score or, 0 to quit, it's really possible for somebody to make a 0 on the test. So it would not be a good sentinel value. Or enter a name or Q to quit. Well, like I said, in Star Trek there's a character named Q. That would not be a good sentinel value. You better pick something else, like just leave it blank or something like that. So that's because there are two kinds of loops. There are counter-based loops, and then there are sentinel value loops. A counter-based loop, is like a range statement. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or underneath it all, when we're printing out a list and we're using that for value in list syntax, there's still a counter behind the screen. I would expand that to saying that there's three kinds of loops: a counter-based loop, a value-based loop, or a sentinel loop. And the sentinel loop is the one that stops it when you type in a specific value. But this is worth mentioning. Probably won't phrase it this way on the exam. What are three kinds of loops? There's counter loops, there's value loops with lists, and then there's sentinel loops. These first two are known as definite loops. Counter and value loops are definite loops. You know how many times it's going to go. It's going to count from 1 to 10. It's going to count through every letter in the name. It's going to count through every score in the test score list. Whereas a sentinel loop is an indefinite list. You don't know whether the user is going to enter one name or a million names. Go to the end and page up. All right, common loop applications. I'm not going to write this down, but defensive programming. We know what defensive programming is, trying to rule out errors. For example, you could validate the data. If they're typing in a month, then you could loop until they type in a valid month, right? Or if they're typing in a credit card, you could check, establish connection with MasterCard and ask whether it's a right credit card, valid, and if not, you'd have to ask again. Another common loop application is accumulating totals or producing a summary report. Why don't we write a few of these down? Common loop applications. To step through a series of data to accumulate totals, to produce summaries, to validate data entry. All right, it's about enough of loops. Let's go to the next chapter. I'm pausing because I believe people are still transcribing. All right, let's go on. Yeah, if you're editing Wikipedia instead, then let me know you're done typing. All right, let's look at chapter 6. That's what we're on. Arrays. Doesn't sound right that our unit only consisted of chapters 5 and 6. That sounds unrealistic. I'll go back and check. Why don't we do that? So when was our exam? Our exam was July 16. No, wait. July 8. And so our homework past that has been loops. Yeah, what do you know? Really? Loops and arrays and modules. All right, we're going to break out and do some lecture again because we have to understand modules. What is a module? It is a named block of code. Sum is a module. Float is a module. Print is a module. Those are just built-in modules that the Python language gives us, right? But when you call sum, it's got to do something, right? It's got to access the array, add up all the numbers. Yeah, it's just nice that somebody else wrote it for us. Or float, I would not even know how to write a function that did a float, so I'm very thankful that Python provides it. So a module is a named block of code, also called a function. It can return values, like the float function returns a number. The sum function returns a number. Print doesn't return a number. So it can return values. If it returns values, it is a fruitful function. I didn't make that word up. Examples. Float and sum are fruitful functions. If it doesn't return a value, it is a void function. Example, print. You don't do A is equal to print. How about input, the input function? You know it's a function because it's got parentheses after it. Not square braces, but parentheses. So is it a fruitful function or a void function? Well, does it return a value? When we use the input statement, are we storing its result in a variable? Come on, guys, you use input on every program you write. When you call input, are you storing its result in a variable? Yeah, so it's a fruitful function. So print is a void function. Input is a fruitful function. You store its result, not read, in a variable. When you define a function, you use the def keyword and give it a name and a parameter list. The parameter list is the stuff between the parentheses. Let's give some examples, and we may as well actually put it into the code. So I'm going to stop green texting it. DEF say goodbye, parentheses, in parentheses, colon. Print bye-bye, in quote, in parentheses. The module name is say goodbye. The parameter list is empty, doesn't have any parameters. Nothing between the parens. That doesn't look right. I'm going to edit that slightly, make that a dash instead. This one doesn't return anything, so it is a void function. And it's only got one line of code in its block. Only one line of code is indented underneath it. Maybe we could call it say underscore goodbye, parentheses, in parentheses. Technically, that's known as invoking the function. I'm going to put a comment, call, or invoke our function. So we have just expanded the capacity of Python. It's doing something that it didn't do before. We can call this as easily as we would call the input function or the float function. That's what functions are for. That's what modules are for. I'm going to write a function that takes three parameters, x, y, and z, and adds them. The function name is add3. It returns the result of the addition. That's what we're going to do. And this ought to be reviewed by and large, because we've been using functions off and on the whole time, and we certainly hit it in the first and the second chapter, but it may seem like it's been a while back. That's why I'm mentioning it again, because it's incredibly important, and I had some questions about it in the past 2 days. All right, so what's the key word that defines a function? We see it big as life in orange up at the top of this page. Yeah, DEF defines the function. And what did I say the name of it was? The function name is add3. Yeah, you're right. You're right. I mean, we had this function. And so you gave me the correct answer. But the function name that we're creating now is add3. So DEF add3 and I want 3 parameters, x, y, and z. They just better be separated by commas because all parameters are separated by commas. X, Y, Z, parentheses in parentheses. All right, what does it return? It returns the addition. Now we could do the addition stored in a temporary variable and return that, or we could just return x plus y plus z. I consider it more correct programming form, better form, if you store the result first. So result equals adding those 3 parameters, x plus y plus z. Then we can return it. So this is a fruitful function. This is a fruitful function because it returns something. What does it return? It returns our result. Return result. Let's call it. Let's print, parentheses, add 3, parentheses, and let's give it 3 values. I don't care what values, 20, comma, 40, comma, 100, in parentheses. In parentheses. Or we could have stored that in a variable first and then printed it. And I'm going to revise it to do that. So I'm going to delete the print and the opening parentheses and say x equals add 3. And since I only have 1 open parentheses, I better only have 1 closing parentheses, so I'm going to delete that. And then I'm going to print the value of x. So the next line is going to be what we always did. Print, quote, x equals, end quote, comma, x. Something like that. So again, we've just customized Python to have a brand new function. One called add3, which takes 3 numbers and adds them and returns the result. So these are what are known as arguments. Arguments fill in the parameter variables. I think I'll go and add a comment up here. And if I ask you to write a function, don't add this kind of comment, right? X, Y, and Z are parameters, or parameter variables, however you want to say it. And 20, 40, and 100 are arguments. The arguments fill in the parameters. I'm going to add that as a comment down here. The arguments fill the parameters. How do you flowchart a function? Flowchart a function like this. If I can find a good, solid end. Right, you have a start. I hope y'all can see this. Can you see my green pen in the back? Shake your head no if you can't see that. I'll load up Lucidchart. Okay. We're going to call the add3 function, and then we're going to print the result. So we're going to put a square here, excuse me, a rectangle, because it's a math, it's a process. And we're going to say x equals add 3, parentheses, and then whatever we have there, 20, comma, 40, comma, 100. However, this is calling our own custom function. So we make it a rectangle with bars. And then we have a print statement, and we know how to put a print, right? Print x, or output x, and then stop. This is our main program, right? It's got a start and a stop. How about that function? How about that module? Here's how you do that. It's got an oval, but instead of a start, it's got the DEF. DEF, what's the module name? Add 3. What are the parameters? What goes into parentheses?
X, Y, Z.
Yep, X, Y, and Z. And then it's got a line of math.
Result equals x plus y plus z. And then instead of a stop, it's got a return. And what does it return? It returns the result. Now this one, goodbye, up there, it didn't have the return keyword, but you still got to put an oval down here. It just says return. So this one, this rectangle with the bars, calls the function, calls the module, and then the return comes back there, so it'll go to the next thing. But you don't draw these lines, because you may call this function, this module, 17 different times in your program, or 117, and you would not want dotted lines going all over your flowchart. That's how you flowchart a function call. That's how you flowchart a function definition. Oval at the top, that has a function name in it. I think the book leaves out the DEF keyword. I like making things more comprehensible to us. So yeah, it's got the DEF keyword. Box with the bars. Now, why didn't I see this nice, good pen beforehand? Right. That's important. If we'd had one or two more lectures, I would make y'all do flowcharts with those. I don't think I did. All right, arrays. Now, we've been lecturing about arrays for 3 days now. So you ought to be able to do these things, right? Declare an array named whatever, right? Books with the names of 3 books you like or hate or whatever. Make them up if you want. Declare an array named numbers that is 20,000 elements long. Zeros. Now, why did I say 20,000 or why did I do 1,000 in the homework assignment? So you would not do this. Don't type this because it's not right. Right? And oh, well, it better have 20,000 zeros. That would take a little time to type. You're not going to do that. What's the syntax for that? We've covered it a few times. If it needs to be 20,000 zeros, what's the first thing after the equal sign?
Asterisk or
Yeah, and before the asterisk is like that. And then what's the thing after the asterisk?
the bracket.
Right, because it's an array like that. And whatever we wanted to fill it with, we put there. For some reason, we wanted 20,000 occurrences of the word Pikachu. And we put Pikachu, you know, between the squares. Write a loop that prints the books array. Why not use a for loop? Oh, I guess I better green text this stuff. Or keep putting it in comments. Why not use a for loop? Unless I tell you to use a while loop, but I'm not gonna. All right, so somebody tell me what I'm going to do. We know the first word is for. We know the second word is a variable name, and you can pick any variable name you want, but what have we been using? I is good for counters. I wouldn't use it for an array. How about value? Right, we were using value today to step through an array or a list. You can't go wrong, though. If you used I and you used it correctly, I don't care. I'm not going to count you wrong. You don't have to use that. For value, what's the next line? I'm stepping through an array, so I'm not going to use a range.
In.
Yep, in space. And it's not a range, so what's my fourth word?
L.
It would be L if that was the name of the array. What is the name of our array? Books. Right. For value in books, colon, parentheses value.
All right. If I ask you to define parallel arrays, know how to do it. I'd rather use my language than the book, but I'm not going to count you off. Kind of summarize it. You don't just copy and paste from the notes unless that's all you can do, right? I'm not going to count you off if you do that, but I prefer one of my definitions. Heck, I did that earlier in the lecture. If I do Control F and look for the word parallel, parallel arrays are multiple arrays of the same length where the elements are linked by their subscripts. You feel like typing that in word for word. That's totally cool. I'm not going to ask you to write an essay about how you use them, right? How come I'm... All right. Write a line of code that will change... No, I guess it better be a comment. Change the first element of the books array to... Let's come up with a book. Dr. Seuss. How do you spell Dr. Seuss? Is that right, or is it E-U-S? Whatever. Okay, since it's bugging me that I don't know how to spell it, Cat in the Hat. How am I going to do that? I'm not inserting or doing any of that fancy stuff that we did when we were talking about lists. I just want to change the first element. Well, how would I print the first element? Heck, that's a good question on its own. Why don't I put that here? Print the first element of the array. All right, we know how to print. I'm going to fill in the first part of it, and then I'm going to sit here until somebody tells me. Print, parentheses, what? What's the first element of the array? Well, what's its index number? 0. Okay, so print the first element of the books array. Where's my cursor? Right, so what am I going to do here? Print parentheses, books, subscript 0, because it's the first element. How about the last one? We've mentioned this 2 days in a row, so I don't mind asking it. How do you get, what's the shortcut for getting the last element? What subscript do you use to jump to the end?
Leave blank.
Not leave it. Yeah, that's if you're doing slicing with the colons. But if you're doing subscripts, in -1. Print the last element. Print parentheses quote books subscript -1. -2 would be second to the last. -3 would be third to the last, and so on. All right, so we want to change the first element of the books array. So, you know, when you're changing something, you have an equal sign. Got to have something in front of the equal sign. What's the name of the array? Books. All right, what am I going to put after the word books? It's the first element, so what do I need to put here?
The period and
Well, we're not going to use a period because we haven't been using periods anywhere else during arrays until we started doing like a dot append and stuff. Instead, to access the first element of the book, how did I print it out? Just like that. Now I want to change it. So what am I going to put here? Square braces. And then what's our index if it's the first element? 0. All right. I'm going to just ask that again until I hear 20 people say it at the same time. What is the first element?
0.
0. Okay. All right. And then 0 is equal to quote the cat in the hat. That's about enough. Since I'm not going to ask questions about lists because we only covered them today, I think that'll make a pretty good exam. One last one. If the array is 20 elements long, what is the lowest index and what is the highest? And when I say the highest, I don't mean using the -1 trick. Now if you put that, I might not count you wrong because technically it does work in Python. But we know the lowest index. The first element is what? 0. And then what's the last one? You went the wrong way. 19. Yep. If it's 20 elements long, you can count to 19. Just like the range statement. Yeah, yeah.
Oh,
All right. No homework. We're at the end. Go ahead and catch up on homework. If it's like 3 or 4 weeks late, I might count off a little bit. Still give you an A or B, though. No reason not to get it done. Let's get it done by Monday. Can't accept work after the final. If you look at your grades and anything is still missing, let me know. I haven't figured out something about Canvas, and I'm going to have. So we skipped actually answering this question, and so we got syntax errors at the end. Books equals square brace, 3 books. Jaws, end quote, Jaws 2, end quote, Jaws 3. Whatever, right? Wait, those are movies. Well, they probably had novelizations as well. Whatever. Hopefully it runs. Yeah.
Or again, how we can extend it.